Hey everybody, welcome back to the shop, and we are in the home shop for this job and this repair. And what we have is a spindle out of a Massy Ferguson tractor. It's got some wear where it rides in the bushings, and the customer asked if this would be something I'd be willing to help them with. And this is a prime job for my flame spray repair, so we're going to go ahead and get this knocked out. Little backstory of what he told me about this tractor is he actually found it at a dealership. It had been at a dealership for several years. I don't recall what the year is. Maybe by the time I put this video out, I'll have a little more info there for you, but it was at a dealership for several years, kind of abandoned. Whoever had owned it didn't want to pay for the repairs that needed done, so they left it there. It was in the back, and they were actually able to acquire it legally through the dealership and brought it home and started taking it apart, and it needs a bunch of work on it. And this was just one thing that needs to be repaired on it, but this was something that they know that I could help them with. So they reached out and said, hey, got some flame spray that I need done. Are you interested? And I said, yep, bring it on. So that's what we got to do. So I'm going to help him get this part of it done, and I think he's got some other work that he's going to need help with later down the road, some other machining, some bigger parts that I think is going to have to be bored and sleeved. So we'll cross that bridge whenever we get there. But I'll get you down here for a tighter shot so you can see what we got to do here. But we're going to be setting this up in the Victor lathe. I'm going to be using my Eutectic flame spray repair equipment right there. Maybe I'll show you guys that. I haven't shown that up close in quite some time for anybody that might be new to the channel. I'll show you what that equipment looks like, the powder that we're going to use, and of course the process that it takes to get this done. Okay? A little bit better look at the spindle here that needs to work. So you have a large journal right here. This is 1 7/8 diameter, and then you have this area right in here that is 1.5 inches in diameter. You can see there's a lot of pitting in here as well, and it has some uneven wear, so it's a little bit closer to size once you get down to this area here, and a lot smaller there. And then the larger journal, I think it's about 5 thou undersized. So these are the bushings right here, by the way, OEM parts, factory replacement parts that get pressed in. But we get up here, we can just use some calipers for this, but 1 inch 493, 495. I didn't get a good reading on that one right there. So a little bit closer to your actual size right there towards the end. But you can see we've got probably between 8 and 10 thousandths wear down here on this end. I'm sure it's not round either. So you can see right there 10 thousandths under 1.5 inches. And then this journal here, let's see kind of measurement we can get with the calipers. Right there, about 5-6 thousandths undersized right there. All right. So we will be going around. So these are grooves right here for grease. Each end of the spindle is drilled and tapped so you can put a grease zerk. All right, so you can pump some grease in there. That's what this groove here is for. And this groove here as well with the cross hole. So we'll flame spray both sides of it and not touch the groove. Same thing here. We'll flame spray this area here, and of course this journal right there as well for the bushing to ride on. This is a lot narrower than what I thought, but whenever we were talking about it, he just said this area right in there. So we'll just build up all this for wherever that bushing is supposed to ride. I'm assuming maybe right there, And then this one is going to go on, and it's going to sit right in there. All right, so we'll go ahead and we'll go down. We're going to use the Victor lathe for this. That's usually the lathe that I use for these repairs. We'll have to set it up, make sure it's running nice and true. And first thing we have to do is mask it, and that is to just protect the areas that we don't want to flame spray, like the splines here. So we'll have to mask it. Then we have to go and do our undercut, and then that's when we get to our buildup. And then once it's built up with a flame spray, let it cool. Come back in here with our carbide tooling and turn it to size. All right, here's a look at the powder that we're going to be using for this repair. It's the Eutectic 21022. I've been using this stuff for years, and it is excellent for bearing and seal journal repairs on shafts. It's just, it's easy to put down, it's easy to machine, it does a great job, leaves good finishes, and perfect for applications like this. One thing to keep in mind, I've had a lot of people over the years ask me about doing shafts like, for example, like a shaft out of a transmission. Those are usually hardened and they have needle bearings that run on the shaft. In an application like that where you have a bearing rolling across a shaft or a surface, this is not the right powder or the process. They have other things you can do, other materials you can use to build up shafts, and I don't get into that, but I just want people to know this is really mainly for just general shaft repairs. If you've got a shaft that's wore out where something runs on it, or you got a bushing or an oil seal or something like that, that's where this powder works really good. All right, this is the masking compound. It's called solution 103. It's like it's a liquid. It's some kind of liquid formula. You use a brush and you just, whenever this is spinning, you just brush it on there, you let it dry, and that's going to keep the metal powder from sticking to outside of the area that you're going to build up. There's a product catalog. Eutectic makes a lot of things, a lot of different rods, welding materials, all different types of powder. They have something for pretty much any application you could think of out there. I know a lot of people don't think of Eutectic Gasoline for a welding supply, but they do have a lot of stuff. Exotic materials, custom welding rods, TIG filler rods, they have it all, okay? But they especially have all of the powders for our flame spray system. So I use the Pterodyne 2000, and I'll show you that. And they have all these different powders made for the Pterodyne system. Depending on what kind of application you got, material that you need, they make something for everything. Now, in the past, I used the Rototech 1A, and I've showed that in some of my earlier videos before I upgraded to the Pterodyne, but they still have powders here designed for the Rototech 1A. So you guys that have acquired this flame spray system in the past, and you may be using that, or you got some old powders that's been around for decades, just know that Eutectic still offers some powders for the old Rototech system, okay? So there's that. I'm going to go ahead and give you a peek at the torch, the equipment that we're using. So this is mine right here. It's the Pterodyne 2000. You can still buy these. I found this one used, and I got a really good deal on it. These are not cheap to buy. So if you can find one used for a good price, that's a good way to get into it. But it was the entire kit that I got for a really good price. I even sent this up there to Eutectic. They checked it out, they took it apart, put new O-rings and seals, and made sure that it was ready to go. So it was in tip-top condition whenever they sent it back. I got the metal hopper for this. It's got the cap with the O-ring seal, so it'll keep moisture out of the powder when it's just kind of resting here and not being used. Another look at that side right there. You have an air line that gets hooked into it as well. This is an air jet that goes on there. So whenever you ignite the torch and you get it set, you go ahead and this right here, you activate the oxygen. It's just shop air is what's coming through there. And using the air jet here actually reduces the amount of smoke and fumes that's put out from the powder. And it also is supposed to help cool the part as you're spraying it as well. Okay, so that always works really good. This is just a flow meter, and whenever I ignite it, I have to use these valves here and get the proper flow adjusted for both the oxygen and fuel. Those are numbers that I just have in my head because I've done it so much. So whenever I light it, you'll see me standing here adjusting it to get these flows correct. All right, and this is just the old shop oxyacetylene cart that's always been in our shop. And I modified it for this stuff right here so that my flame spray equipment could stay on it all the time. If I need to use a larger torch, I just unscrew it here and put the larger torch body and lay it up here. I also have the smaller medium size on here ready to go as well. All you got to do is just have these Y splitters right there so you can have 2 oxygen and 2 acetylene lines to have 2 separate size torches ready to go. All right, and this is the lathe we're going to use. This is the old Victor 1660, subject of many of my videos. This has been in the shop for a very long time. I believe Dad bought this back around maybe 1980, something like that. It was used, and he bought it. It's done a lot of work. It's made a lot of money for the shop, and it always does a good job. It is an older machine, so it's not perfect. It's got wear in the ways. So I keep the flame spray in this home shop and only on these two lathes right here because I don't want this in the new shop getting around the new equipment. It is a little bit abrasive, but I'm not concerned about it right here. What you'll see me do is I always cover the ways up with some fiberglass blankets. And whenever I'm done with it, I remove those and I always wipe the ways off. So if any powder is settled on there, I just wipe it off. But I just keep that on these older machines and off of the new stuff. So I think that's it. I did want to mention this 6-jaw self-centering chuck. If I can't get the shaft to run true with it, we're going to take this off, and I got a 4-jaw chuck that we'll put on here so we can get that shaft trued up. So that's what we'll work on next. So the 6-jaw is going to work fine to help me establish the center and end of that. I'm going to have to put the 4-jaw on here so I can chuck those splines and get it running nice and true, but I need a nice true center on this end to be able to put the live center in there. So we've got the compound slide set at 30 degrees. I've got this small boring bar in the tool holder there so we can just cut a nice true center. And indicator set up so that you guys can see. We got this running less than 1/1000th of an inch, and I think that's going to be fine just right there where it's at. All right, so we'll get the center cut, and we got to swap out that chuck. Don't need a large center, we just need to clean it up. Just taking 5/1000ths at a pass. A little bit more, it's still actually in the threads there. That's looking good. I think I'm gonna go 5 more thousandths here. It's cleaned up all the way around. That should provide us a nice center right there. So cutting that center reminded me one thing I do need to do is to clean it, wash it out. There's probably a lot of grease residue still inside the shaft that needs to be cleaned out. You don't want that stuff getting hot, melting, and flinging out on you whenever you're flame spraying. Any kind of oil or grease just ruins the coating if that happens. So I'll go down to the smart washer. We'll see if we can get whatever grease is in there kind of washed and blown out. Same on this end there as well. Anytime you're working on parts that you have to weld or flame spray, let's just mention flame spray for our case here. You always want to clean them. Make sure all the oil and grease is out of it. You got holes like this, these grease holes. Just make sure that you wash them and blow them out really well. Try to get all that grease out that you can. So after I wash this really well, I'm going to use the compressed air and blow it out, and then I'll use some of the CRC heavy duty degreaser and blow in there, and that'll help kind of dry any kind of residue that might still be in there. It'll help blow it out and dry it too. I think that side's pretty good. You can see it coming out of that grease hole. Let's go ahead and get this side too. Still got some in there that it's getting out. We're going to use some degreaser. I am using the non-chlorinated degreaser, by the way. See if we can get a little bit up inside there. Just do that a couple times and see if we can get all that grease residue out of there. I've got this chucked up in our 6-jaw, and I think this is going to be just fine. That's bouncing within 1/1000th of an inch. This is one of the better areas of the shaft. All right, and if we move the indicator down here to this area, this is a good area of the shaft as well. This journal right in here, it's within a thousandths as well. So nothing wrong with that. We're just gonna leave that right where it's at and not have to swap out the chuck. All right, we're gonna go ahead and put our mask on there. This stuff right here. Just shake it up good. Just got these towels down here to catch any drip or any that might want to fling off. So we're not going to go down into that grease groove. We're just going to go right up next to it. So that amount right there is all we need, and then we're going to put a little bit in that. That's another groove right there. What I'm going to do is just kind of go ahead and brush it down into those splines a little bit, just to help keep it from trying to stick down in there. And go through there later and brush that out. All right, we'll just let that dry. All right, we're gonna go ahead and get it undercut now. I am using this is a tongue alloy threading tool that I'm gonna use, and we're just gonna go just up before each one of those undercut there where those grooves are. We're only gonna take probably about 20 thousandths. Just come up and get it touching like that right there. Let me get a 0 established. This is a 10 thousandths pass, and we'll just come back and clean it up with another 10 thou. I'm just gonna go right up to that groove. And you can see it didn't quite clean it up there. Another reason why we gotta go deeper. I just like to get a cut established and see what the wear is looking like. Just go ahead and back it up. Take a little bit more up to that shoulder there. Go in another 10. Cut it again. And if it doesn't clean it up, you can take another pass on there. 20 thou is a good depth to go on most of this though. All right, so that's pretty good. We'll back off. I should have put some masking down in that groove there, and I did not do that, but I'm not gonna worry about it now. We're ready to go. There's like rust and corrosion down inside there. So that'll help keep it from sticking so bad. Look to this side. Let's go back to our 0. There's our 0. Back it up and then engage it. Come back to our start and take another 10 thou. All right, that should be good for our undercut. Now we are going to go in there and cut a thread on there as well, but we'll go ahead and finish this side first. All right, there's our 0. $10,000 just like the first. And we'll do the same thing. We're gonna stop up where that grease groove is and then jump it and go to the other side. I just overlooked those whenever I was masking them, but no big deal. Go ahead and finish this side. Take another 10 thou. Yeah, it should be good, right about there. Now you can see the pitting and corrosion in there. And we'll go back and take our 10th thou. And I just want to stop it and make sure that it cleaned up all the pitting. It looks like there is just a very minor amount. I can still see some down there. Yep, I can still see some pitting. So we're going to take another 5 thousandths off this one journal. All right, I think that got up most of the pitting right there. All right, next up, we're going to cut a thread on all 4 of those journals that we undercut. All right, well, we'll just start right here, and I'll go right back into where we had finished this cut. So I've got the lathe set up to cut 24 threads per inch. Let me double check that. 24 is fine. Any kind of fine pitches will work for this. I'm going to go in 15 thousandths, straight in feed, and engage it. We're just going to make one pass. 5, 10, 15. Just like that. All right, that one's on 20, 10 and 15. Gauge the half nut. All right, let's do the same thing down here. 10, 15. That one looks a little funky right there because of the way that I engaged it. I kind of forced the half nuts to go into the lead screw. That's why it's better to just kind of lightly put a little pressure on the handle and let it fall in. Sometimes we can get in a little hurry getting those half nuts engaged. Now this one's going to be real quick right here. 10, 15. So you got to do the quick draw method. Just like that. All right, so this guy is ready to flame spray. This is the point where I usually take a clean rag and just kind of wipe all the ways down, try to get rid of the whey oil off of it on both sides, just to kind of help eliminate any kind of dust getting on there from the powder. And also whenever I put my fiberglass fire blanket on here, I don't want the oil getting all up on the fiberglass as well. And then once you spray it and you're ready to go, you pull the fire blanket off and I just wipe it down one more time. One more note, we're going to take this is a good life center. I'm going to take that out and I'm going to go ahead and put in an old wore out center that we use for welding that still works really good. This guy, it still feels smooth as well. $35 and $75 are there. right, first side built up. It looks good. All right, there's our build-up. Everything's cooled down. I cleaned the center, put a good live center in there. Got our tools set up, and we are ready to get these journals turned down to size. I usually start by kind of cutting the ends off a little bit, getting that rough powder off of it. Knocking off the highs. So that's obviously the highest spots of the buildup right there. And that gives you a place that you can measure it and see how much you got to take off. All right, we've got 55 thousandths to come off from right there. So you don't take heavy cuts on this. About 20 thousandths a pass is what you want when you're roughing it anyway. Do that because it leaves little fine dust on the surface when you're trying to mic it. It will make the mic stick a little bit. Okay, a couple more passes and we'll have it down there. All right, that was my semi-finish pass. Now we're going to take a measurement. So even with that air, you can still feel a little bit of that dust on there. And don't mind these holes. That's where that grease groove is. I'm hoping that once we make this finished pass, it'll peel that out of there. All right, so we got 8 thousandths to bring it to our size. I usually try to leave it about 1 thousandths over so we can polish it down nicely. So I'm going to take 7 thousandths on the dial and we'll make our finished pass. We'll check our size here. 1 thousandths over the way I want it, so we'll be able to polish that. I was hoping the center would come out, but I'm going to have to go in there with the tool where the grease groove is and try to get that to come out as same as this groove right here. And then besides that, we just got a little bit of cleanup right there where it tried to stick. You can see it's coming off with my finger there because of the masking. Yeah, masking did its job. Sometimes that's all you need to do, but let's go ahead and trim that a little bit. All right, come to the center where our grease groove is. Do the same thing right there. It's looking good. That rust did its job, kept it from sticking. All right, we just need to do a little polishing and we'll be good to go. There's another spot right there where it stuck a little bit harder. Sometimes all you got to do is just get your tool in there. Come on, lathe. I want neutral. There it goes. Got it. Okay. This should be good. We just got to do some polishing on it now. But we'll go ahead and move down to this larger journal and get that one turned, and we'll polish both of them at the same time. Like before, we kind of start with the high spot and I go to each direction, kind of knocking off the ends. I can tell that it's a little bit higher in that area. You can see there. Come back to our high spot and take a pass. Let's go ahead and get a measurement on it and see where we're at on our diameter. All right, got about 60 thousandths to come down. All right, this will be our finished cut here, taking 12 thousandths. All right, that looks good. All right, we got the 1/1000ths to polish down to bring it to 1 7/8. So all we got left here, we need to come in here and just get that grease groove cut out. Doesn't hurt to clean it up. It cleans up that edge so it's got a nice smooth transition to the buildup. And it looks good. I'm going to come in here with some of this 220 grit emery paper and go ahead and give it just a quick polish. Sometimes it doesn't take much to take it down that thousandths, and if it seems to polish out and I can't get it to come down, then you can certainly bump it up to a higher grit. So I've also got this 120 grit there as well if we need to use that. Just hit it quickly like that, just to kind of knock down any of the high spots of the tool marks. And you can see where you're at. I got to bring the mic down. And I quickly brought it down a 1/2 thousandth, so it just needs a little bit more. Looks like a couple of tenths left to go. Maybe about 2 tenths. I'm going to go ahead and work on this side now. Bring it back out to 1 7/8. That one we still got about 8 tenths and 8 tenths. See, this is one of those that is not wanting to come down, even that polishing that I'm doing there. I'm still at 5 tenths over on that one right there. And this one is 6 tenths over on that one. And it's already kind of slicked down. You can see it's starting to look nice, but I need a little bit more. That's where I'm going to grab this 120 grit and go ahead and cut it just a little bit with that. That buildup is pretty tough. Sometimes it takes a little bit more aggressiveness to get it down. So I can tell that I'm cutting it there. This one needs a little bit more than that side. Just move the paper. Once you get it down to about 1, maybe 2 tenths over your finish, that's when you go back to your finer grit and polish it up, and then Scotch-Brite at the end. Should be putting us really close where we want to be now. So that one's got 3/10. This one has 2/10 right there. So just more of the same. I'm just going to continue to polish this, both of these, to get them down to size, and then we are going to clean up the rest of it too. We'll polish this, make the whole thing look nice and fresh. All right, we got both journals down there to the size we need. Just need to do a little bit more cleanup there. I usually just kind of wait until I'm done polishing it. That's the masking compound right there. That's why I wait till last, because it'll kind of get clogged up in your paper there. Yep, and then we'll go back to our 220. Once we're done polishing this side, I'll flip it around and make sure these splines down here are cleaned up nice. We'll get some thin strips to get these oil or grease screws. I just got a brush here for the splines. It's just got a little bit of dust down in there. So these are the new bushings that will be going in. Let's see how they fit. Just like it's supposed to. Just like it's supposed to. That one's got a little bit more friction on it. That should be good. That's a huge improvement over what was on there. It had one area up here towards the top that was at least 10 thousandths under, and this one was 5 thousandths under there. So once these are pressed into the housing, it should be the proper fit on these guys. This job is pretty much done. I'm going to go ahead and take it out of the chuck, flip it around, and just clean up these other splines down here. But our buildup looks great. It's on size. Everything looks good. Whenever these jobs are done, what I do is I take and I clean these chucks off. It just gets a little bit of that dust on it. I'm just making sure it's off of the chuck jaws. Just a little bit of that powder built up right there at the very end of the spline, so I'm just making sure that's all knocked out of there. None of it's stuck, it's just kind of sitting down in those grooves. Looks like we got it all out of there. One little spot right there. Okay, that looks good. All right, I think we are finished up. All right, guys, well, that's it for this job. This one's completed, and I'm happy with the outcome. It looks good. You can see just how well the eutectic flame spray buildup works for jobs like this, for shafts that have bearing fits and seal fits that have worn down. It's a great application for like that. It's low heat. I know people are concerned that flame spray, you're going to warp it. It does just the opposite. If you're on here arc welding, it's going to warp the shaft. This process that I use is designed for doing jobs like this. It's low heat and it's an even heat. Since the part is rotating, you're applying even heat on there while you're building it up, allowing the part or the shaft to stay nice and straight. And that's just what this one did here too. So it's a great way to repair shafts that otherwise would be very expensive to replace or more difficult to repair using other methods. And it always works well for me. So I'm real happy with the outcome. I think it looks good, and hopefully this is gonna put this part back in service and last for many, many more years to come. So anyway, this one's wrapped up and finished. I hope you guys enjoyed watching. I always enjoy sharing this process with you whenever we get jobs like this in to do the flame spray. And I will see you on the next project. All right, see you then.